So now today's topic is going to be Pythagorean identity. Use the Pythagorean identity. Okay, use the Pythagorean identity. In some books, they will call it use trigonometric identities. So Pythagorean identity is just one of the trigonometric identities. All right. So now these for us to use this, there are certain formulas we have to remember. So one of those formulas we must remember is our SOHCAHTOA. And okay, let me label it like 1, 2, 3. 1 is SOHCAHTOA. 2 is that hold on, please. Okay, so one of them is SOHCAHTOA. The second one is sin theta. No, I'm sorry, tangent theta is equal to sin theta over cos theta. These are the formulas we must remember. The third one is that y squared plus x squared is equal to 1. And then the fourth one we must remember is sin squared theta plus cos squared theta is equal to 1. So these are basic formulas we have to remember in order for us to be able to solve our problem. Okay, so having said that, remember all these things are still under unit circle. All these things are still under unit circle. So what did we call this? What did we call this one?
The standard equation for circles or unit circles.
A unit circle, thank you. All right. And then this one is the trigonometric identity, Pythagorean trigonometric identity. So this is actually the one that is Pythagorean trigonometric identity. This one is your regular SOHCAHTOA, your basic trigonometric ratio. And this is the first, I call this the first trig identity that is derived from your SOHCAHTOA in a unit circle. All right. So having said that, so because we are dealing with a unit circle, so let's just draw a very nice circle. Draw a circle, please. Let your circle be better than mine. And then in this circle, of course, always create center of your circle. So create a center and draw a vertical line that cuts across it. Then draw another horizontal line that cuts across it. This is usually your y-axis, and this is usually your x-axis, always. And so now it has 4 quadrants, right? So this is quadrant 1, quadrant 1. This one is quad 2, this side, quad 2. And this side is quad 3, and this side is quad 4. Actually, they write it with Roman, I think they write it with Roman figures. Okay, so now on this 4 quadrants, let us look at how the trig ratios are represented in each of the quadrants. So we can use a different line and just draw our unit circle, radius 1. And we have and angle theta. Okay, then we draw the same thing on the second quadrant. We have angle theta. Then we draw the same thing on the third quadrant. We have angle theta. And then we draw the last thing on the fourth quadrant. We have angle theta as well. Now, in each of these are the coordinates. These are the coordinates, coordinate points. So in each of it, so you can see you have your y-axis here and you have your x-axis. So in this particular first quadrant, both y is positive, y is positive, and x is also what? Positive in the first quadrant. In the second quadrant, you can see that y is positive and x is negative. You see, any value from this point of 0 to the other side is negative. So x is negative. On the third quadrant, you can see that y is negative and x is also negative. X is also negative. Then on the fourth quadrant, you can see that y is negative and x is positive. X is positive. Okay, so based on this, if you pick any of the, what is it called? If you pick any of the trigonometric ratios, any quadrant, so pick a number. Let's try it using SOHCAHTOA.
3.
Quadrant 3, okay. So in quadrant 3, do you want us to determine sine or cosine or tangent?
Cosine.
Okay, so in quadrant 3, so let's do it here. So we are doing quad 3, and you want cosine. So cosine theta is always adjacent over hypotenuse. So in this case, you can see the adjacent is what? Opposite is the y-axis. The opposite is the y-axis. The adjacent is the x-axis. You see? I don't know how to write this again. So now in quadrant 3, opposite is the y-axis. This is the opposite. This one is the adjacent, and this one is the hypotenuse, which is the 1. So the adjacent is negative x. So you have negative x over the hypotenuse is 1. So that cos theta is equal to negative x in third quadrant. In third quadrant, cos theta is negative. Okay. In the same third quadrant, let's see sine theta. Sine theta is equal to, sine is always opposite over what? Hypotenuse. So then in this third quadrant, opposite is negative what? Negative y. So you have negative y, and then the hypotenuse is 1.
Negative x.
Sine is opposite over hypotenuse. Hypotenuse is always 1, is the unit circle.
The longest side.
Yeah, the longest side. So the opposite is definitely negative y. So the hypotenuse is definitely y. So where are you getting negative x, Abu?
I got it based on like it was from the chart, but I was
yeah. So from this chart, this is a third quadrant, which is you selected it, right? So on this third quadrant, the opposite is this one.
I didn't see the 1. Oh, bad.
Okay, this is 1 here. Remember, we are dealing with unit circles, so the radius is always going to be 1 if it's a unit circle. If it is not a unit circle, that's a different thing altogether. The radius can be any other number other than 1. All right. So, so we are correct in this case. Sine theta is going to be negative y. So that's for third quadrant. Every angle, the sine of every angle in third quadrant is always negative. That's what this thing shows us. Now let's do tangent. Tangent of theta is always what? Opposite over what? Adjacent. So in this case, it is going to be opposite is negative y, and adjacent is negative x. So negative crosses negative. So tangent of theta is going to be y over x, which is a positive number in the third quadrant. So in the third quadrant, it is a positive number. All right. So now, based on what we have just explained, let me give you a chart that you can work with. You can, use as a reference point right now. Let me write a chart for you. And we are going to use that chart right away, but let me write it so that everybody can have access to it. So just draw your 4 quadrants. And then this is always your y-axis, and this is always your x-axis. And you can, of course, write your quad 1, quad 2, quad 3. They usually write it with Roman numeral, but it doesn't really matter. I just want you to know what is inside there. So, and then quad 4. So now in each of them, we are going to indicate the sine, the cosine, and the tangent. So we have sine theta, cos theta, and tangent theta. So in the first quadrant, all of them are positive. All of them are positive. In the second quadrant, sine theta is positive. Cos theta is negative. And tangent theta is also negative. Now, in the third quadrant, from what we just did right now, we actually proved it here. So sine theta is negative, then cos theta is also negative, and tangent theta is a positive value. Now, on the fourth quadrant, sine theta is negative, cos theta is positive, and tangent theta is negative. So I want you to make reference to this chart, because right now I am going to give you a problem. Then I will ask you, in the third quadrant, is cos theta negative or positive? So you look at the chart, you tell me. All right. So, don't worry about memorizing it, but as you read through it, it will stick into your brain. But right now, don't worry about memorizing it. Just use your paper as a reference point right now. Okay?